Dear students, let us learn how to design a synchronous counter using ICs today. And for our study, we are going to consider IC 74163, which is a 4-bit synchronous counter. Because it is a 4-bit counter, it can count 2 power 4 clock pulses. That means 2 power 4 equal to 16 clock pulses, that is ranging from 0 to 15. Because there are 4 bits, it requires 4 flip-flops. Let us see the pin diagram of an IC 74163. You can see this. First VCC and ground pins are there. These are the power supply pins which are used to make this IC on. Then you can see clear bar, which is a active low signal, and it is used to make the counter output 0. You know already in flip-flops. And you can also see load bar. It is an active low signal, and it is used to load the starting value of counter with the present inputs. DCBA, any present inputs you can have. That means initial value or starting value can be from 0000 or any other value. And fourth point, that is clock pulse. Through these pins, clock pulses are applied to the counter for counting operation, right? And then we have enable P and enable trickle pins. These are the two enable pins. These are the active high signals. So when both are on, then only this counter starts counting. Otherwise, counter enters into hold state. What is a hold state? Next state will be equal to previous state. Then we can see the sixth point, that is DCBA. These are the 4 bits input input pins. These are the 4 values which are loaded into the counter as starting value. So when load bar is in on condition. And next we can see the 7th point, that is QD, QC, QB, QA. These are the 4-bit outputs which indicates the count value. That means 4 flip-flops outputs. Okay. Then we can also see RCO, which is a ripple carry output. Now this ripple carry is generated whenever the counter reaches its maximum value, right? Now with this basic knowledge on counter IC 74163, let us see how to design a counter which can start from 0000, 4 zeros to the maximum 1111. That means count from 0 to 15. Okay, and here it has to count from 0 to 15, and the initial value is 000. Therefore, what we do now, we connect DCBA all inputs to the ground, because all should be 0, therefore it should be connected to ground. And then for counting operation, clear bar must be off, because if it is clear bar is in on, the counter output will be 0, therefore it should be off. Similarly, load bar must be off, because we want to give all the initial values 0000, and we have connected to ground. And similarly, clear bar, that means a clear bar equal to 1, load bar equal to 1, and then enable P, that means enable parallel and enable trickle. These are the active high input signals, therefore these should be 1 and 1. Therefore all these 4 inputs should be connected to VCC. Okay, all these connections which I have mentioned are shown clearly in this pin diagram. You can see all the respective connections. Now coming to truth table, you can see clear bar, load bar, enable, parallel, enable, trickle, clock, and then QB, QD, QC, QB, QA, all the previous states, and then present state. Next state you can say QD, QC, QB, QA, then RCO. You know that RCO is ripple carry output. It is generated only when the counter reaches its maximum value. So all other values are 0, and only when it reaches to all 1, 1, 1, 1, 15, then it is generated as 1. Okay, now coming to this clock pulse. Okay, whenever there is clock, only counter counts. And before that, you can say enable pin, enable parallel and enable trickle. Only when these are high, counter starts counting. If these are 0, the counter will be in hold state. Okay, then clear bar, the output will be 000, and when clear bar equal to 1, the output will be, next state will be corresponding value D, C, B, A. Okay. Now when clear bar and load bar are 1, 1, 1, and then when clear bar and load bar are 1, 1, 1, then what happens now? Enable P and enable T both should be 1, otherwise counter will not count. It will be in whole state, you can see in truth table. Then when all these are 1s, you can see the counter starts counting from all zeros to all 1s, present state and next state you can observe. Like this you can explain about a counter, 4-bit synchronous counter using IC 74163. Hope you followed, and if you have any doubts, you please mention your doubts in comment section. I will clarify your doubts. Thank you. God bless you.